Welcome to the world of OMS and to our bespoke range of precision hand tools. Knowing if a pipe is straight or not can be absolutely vital, especially in the field of pipeline construction, where tolerances are critical. OMS's solution to mitigate this risk is the Pipe Straightness tool. The laser module is firstly secured in place using the magnetic clamp. Aligning it with the target module then allows the user to gather measurements in the field accurate to within 1 millimeter. The OMS system uses a laser beam as a straight line in space. If the pipe is straight, then the laser will point to the center of the target module. However, if the pipe is not true, its degree and angle of bend can be accurately measured. By determining a pipe's straightness, its suitability for a specific role can be quickly assessed and any potential risk mitigated. When welded, SCRs and other fatigue-sensitive pipes require a minimum high-low gap. The question is how to check that gap reliably in the field prior to closed-gap welding. The answer is OMS's closed-gap HiLo tool. The unit has been designed for ease of use and is available in a magnetic option, allowing the operator to use both hands to take highly accurate measurements that are consistently repeatable and free from human error. The OMS tool uses a two-blade system to measure the high-low gap between the pipe end bevels. The LED meter reading is accurate within 0.05 of a millimeter, providing vital data that could avoid delays or serious malfunctions. Open gap welded SCRs and other fatigue sensitive pipes must adhere to stringent high-low gap tolerance levels. The importance of checking the high-low gap reliably in the field prior to welding is therefore paramount. The OMS solution is the open gap HiLo tool. Once securely attached to the pipe's surface at the join between the two aligned pipes, the tool is capable of quickly producing highly accurate readings of the internal high-low geometry. The OMS tool is inserted into the open gap, and the twin blades rotated until they hook onto the interior pipe lips. The difference in the height is recorded, providing a high-low gap measurement accurate to 1/500th of a millimeter, quickly allowing the operator to ascertain if the gap falls within the specified tolerance levels, and so mitigating risk. After pipes have been welded, the grounding off process ensures that the surfaces are flush. However, the process can remove too much material from the weld and compromise the integrity of the join, creating a potential risk. OMS's Gurth Whirlpool has been designed to mitigate this risk by measuring the deviation of the pipe wall across a weld. After the unit has been electromagnetically secured in place, the operator is able to take precise measurements to ensure the integrity of the weld. The unit is equipped with a highly sensitive probe, which acts as a measuring point. As it passes over the weld, the positive or negative measurements will ascertain the profile and degree of deviation, enabling the operator to evaluate the integrity of the join and so mitigate the potential risk of weld failure. Pipes with outer square ends can cause a variety of problems for pipeline welders, particularly when used in the HiLow process. So how can operators mitigate this risk? The solution is OMS's Nsquareness tool. The three-part tool is quickly assembled on site before being aligned on the pipe. The user is then able to manually adjust the tool to produce a measurement at 180 degrees across the pipe end to determine the end squareness. The tool is equipped with a highly accurate measuring blade, which when pressed against the bottom of the pipe will give a measurement relative to the top, so calculating the squareness of the pipe end, and its suitability to be welded to the adjoining pipe, helping to mitigate the risk of weld failure. A critical element in the successful welding of pipes is the profile of the pipe end bevel. Both its depth and angle need to be within a specified tight tolerance, otherwise there's a risk of weld failure. To help mitigate this risk, OMS has produced a Bevel Tool, which can be used on-site by a single operator to check a pipe's bevel profile against a specified tolerance. In one single action, the operator can gather all the data needed to form a highly accurate profile of a J-prep bevel. The tool is equipped with 3 meter modules, recording data from 3 highly accurate sensors, measuring the angle, depth and thickness of the bevel. This data is then fed into a computer, which will assess if it meets the stringent requirements for quality assurance purposes. Pipe end outer straightness can cause critical issues in the pipeline, particularly for welders. Any irregularities must be detected expediently prior to welding, but how best to do this quickly and cost effectively? The answer is with OMS's Hawking Tool. The tool consists of a perfectly straight lightweight beam with a precision measuring probe at one end. Designed for use by a single operator, the measurement process is accurate, easy to use and totally reliable. Once inserted into the pipe, the tool can be positioned to produce a number of readings and measure any out of straightness anomalies. Once issues are identified, action can be taken before the welding process and so reduce the risk of subsequent weld failure. Pipe ovality or out of roundness can lead to multiple welding issues. So how can we ensure that pipes will fit together within specified tolerance levels? The solution is OMS's Manual Tool. The unit is quickly assembled in the field and is designed to be used by a single operator. Once calibrated, it's introduced into the pipe end. The measuring arm is then manually rotated and in so doing records vital internal dimensioning data. As the tool's laser sensor makes its 360-degree scan, it measures minimum and maximum internal diameter readings that provide an accurate picture of the pipe's internal roundness. This data helps welders to assess pipe end-to-end fit suitability, reducing delays and the risk of weld failure. OMS, precision solutions for performance demanding environments.